In this video, we are just going to look at some solids of rotation problems. We are just going to look at how to set up our integrals. We're not going to solve them. We're just going to look at how to set them up so that you can just see whether you are comfortable with being given some functions and being given an axis of rotation and then knowing how to set up your integral. So what we have to do is we have to find the volume of the solid obtained by rotating the region bounded by the given curves about the specified axis. Right, so we have, firstly, number 7. It is under the review problems from section 5.5, which says y equals 2x, y equals x squared, and we want to rotate it about the x-axis. All right, so let's just get a picture of what those two functions will look like. So we just have a straight line, y equals x, and then we also have a parabola, right? And they are going to intersect at some point, so you find where they intersect. And we are going to be rotating them about the x-axis, right? So we are rotating about the x-axis. I'm going to use the washer method to find my volume. So what you would have to do is, let me just draw in what the washer is going to look like. All right. So we are going to need our outer radius, and we are going to have to take our outer radius squared minus our inner radius squared. This is going to be the outer radius, and this is going to be the inner radius. And then we are going to be integrating with respect to x. So we're integrating from 0 to where these two curves intersect. To find where they intersect, we set them equal to each other. So we have 2x equals x squared. And that we can write as 0 equals x squared minus 2x. So we have 0 equals x and then x minus 2. So that means that they intersect at 0 and 2, right? So this value here is 2. Right, so now I'm just going to set up my integral. I have the volume is going to be, I'm using the washer method, so it's pi, and then I have the integral from 0 to 2, and then I have my outer radius squared. My outer radius is going to be my straight line. So let's just fill that in. This is the outer radius, and it is going to be 2x, and this is my inner radius, which is going to be my x squared. So I have my outer radius squared minus, and then I have my inner radius squared, so it's x squared squared, and then dx. If you were not sure what the picture looked like, you could just verify for yourself which one is the outer radius and which one is the inner radius by taking some value in the interval that we are integrating over from 0 to 2 and substituting it into both functions. Let's say you take the value where x is 1, then you substitute it into 2x and you get 2, and you substitute it into x squared and you get 4. So you'll clearly see that x squared is on top and 2x is on the bottom. And it cannot change inside that interval since they only intersect at 2 places. So if they intersect at 2 places, that means we have one interval, and you can find which one is on the top, which one is on the bottom. The next one we have is number 12, and it says y equals tan x, y equals x, x equals pi over 3, and we want to rotate it about the y-axis. All right, so let's just first look at what this picture will look like. So we have y equals tan x, which looks like this. Then we also have y equals x, which is our straight line. And we also have x equals pi over 3, which is that. So what we need to do is we need to take this area and we need to rotate it about the y-axis, right? So let me just fill this in. This is pi over 3. Then we have our function here, which is our tan x, and we have our function here, which is just x. We are rotating about the y-axis, so I'm going to use the shells method here. In other words, what I'm going to do is I'm going to create cylindrical shells, infinitely many of them, and add all of them together. So one shell will look something like this. So what we would need to do is we would need to work out our height of the shell. So the height of a shell is going to be what? We have our top function, which is tan x, minus our bottom, which is x. Right? You could also use the washer method here. In the previous one, you could have also used the shells method. Right? So let's just write down what we get. So we are going to get the volume by taking the integral. And remember our bounds we are integrating from 0 to pi over 3. Right? Then we have 2 pi multiplied by x, which is going to be the radius of a shell. Right? So this is the radius. And then we have the height of the shell, which is just tan x minus x dx. And we're not going to solve this once again. All right, so then we just write that in. This is the height. If you wanted to do it in terms of washers, as I said, you could also do that. What you would do in that case is you would have a washer which would look something like this. Let's try and draw it in here. Not like that. Like that. And then you'll have an inner radius. So what you would need to do then is you would be integrating in terms of y. So you would need to know what that y value is there. So let's just call that y, or let's just call that, sorry, some value c. So you would have to know what that value is, and you would have to find your functions in terms of y, and then you would have to integrate those, right? So in this case, I think it was perhaps a little bit more straightforward to use the shells method. Next, I'm going to look at number 14. It says y equals root x and y equals x squared, and we are rotating it about y equals 2. So it's not just about the x or y axis, right? So once again, let's just see what that would look like. So y equals root x is the same as having y squared equals x. So it's just basically a parabola on its side with only the positive y values. Since we don't have a plus minus there, we only have the positive y values. And then we also have y equals x squared, which looks like this. So then we just fill those in there. So this is x squared, and the top one is root x. All right, so we want to rotate this about y equals 2. So this is y equals 2. That's what we want to rotate it about. So we need to know where do they intersect, and then we also have to decide which method we want to use. Right, so what we're going to do is we are going to use a washer method in this case. So whenever it's possible to use a method such that you can use your functions the way they are given. In other words, I can use it as root x or x squared. That's the simplest way. Otherwise, you can always write your functions in terms of y, and then you can also use your shells method, right? But I'm just going to use my washer method here. So let's just draw in what a washer will look like. So a washer will look something like this. So there we will have our inside radius and then our outside radius, right? So what we need is, let's draw it in like this. This gives us our inside radius. What is that value going to be? Well, that value is going to be 2 minus root x. Then our outside radius is going to be that. And that's going to be 2 minus x squared. Right? So let's set up our integral. Our integral for the volume is going to be the integral from, we still need to find out where they intersect, right? So you can just set them equal to each other. Then you have root x equals x squared, which means x equals x to the 4, which means that we have 0 equals x to the 4 minus x. So 0 equals x, and then we have x cubed minus 1. So that means x equals 0 or x equals 1. So we know this value is 1, right? So we are integrating from 0 to 1. Then we have pi, and then we have our outside radius squared. So it's 2 minus root x squared minus our inside radius also squared dx.